December 8th. So we are kind of right in the thick of things. Wanted to start off today. Hopefully, we get a few more people to join us. We're kind of light today. But I wanted to start doing something a little bit different. It's kind of like a meme challenge. So the point of it is to open up, kind of relax, get started. So it's just going to be a couple different memes. You're going to decide which one relates to you more, and then you're going to put that number, corresponding number, in the chat. So let's pull that up, and you'll kind of see what I mean. If you guys want to turn your cameras on, absolutely, I always encourage it. Again, I think it's a way to stay a little bit more engaged. So let's pick a number. Let's say 21. All right, are we like Winnie the Pooh here, or I'm not sure what that second meme is, but this guy, he looks like he's kind of sleepy going into tuxedo. Type in the chat, are we more of a 1 or a 2 today? Where are we at? All right, Cardon's ready to go. He's ready to, Georgia, right, we're ready to calculate the world's problems. Preston's like, I'm still chilling a little bit. All right, let's take a look. What about, I think that was, oh, here we go. We got any cat people? Even if you're not a cat, there's probably a meme that would work for you. Sees anyone else? No. All right, 7, 2, 4. Oh, we're all over the place. 6. So a 4, you must not have eaten breakfast yet. Let's see here. How about number 10? This is all celebrities, it looks like. Might even be the same person. A 5, that looks, you're ready to have some. Oh, Preston's feeling fabulous. Okay. All right. Let's wrap this up. We'll do one more. I'm looking for a volunteer to pick a number. First one to unmute or type in the chat. 9? Or was that from the last one? All right, I heard 9. Let's do it. Oh, okay. Are we veering off at the last second, or are we super, super happy? Which one? 1 or 2? All right, that's good. Everyone seems to be happy. All right, we're ready to go. So, as I'm sure you guys know, the word of our month is empathy. So, as we can kind of see throughout that whole activity, it truly, we all can be feeling different things at different times. We can be in different places. So, as you go throughout, not just our class, but as you go throughout life in general, make sure that you keep that in mind, that someone else may not be feeling the exact same way as you are. And that's kind of, I always think about the definition of empathy is walking a mile in someone else's shoes. And then you could feel for them, or you'd know sort of where they're at and what they came from. So moving on, again, we've got our agenda. We've got a busy day. Oops, no, we don't need to do that. Okay, going to talk, we did our warm up. We'll talk about exponent rules, polynomial functions, even and odd, adding, subtracting, and multiplying. You'll get a chance, a lot of time to practice and kind of come up with stuff. And then we will talk about the Class Connect assignment. So we did this already. Exponent rules. So I'm going to put the link in the chat, but I want you to look at these. Okay, these are all different examples here. These are 3 different examples. The questions in blue, the answers in red. I want you guys to come up with rules that work for this. So again, I'm going to type this into the chat. I want you guys to make a sticky note and tell me, what do you know about these things? Looking at these examples, what can you come up with? And I'll put those up. So click the link in the chat to go to the Jamboard. And what rule can you come up with that describes either something on the right here with the powers, something about combining these things, what happens with these exponents. That's what I want us to focus on. So I can't quite jump from one to the other. So let's see. All right, Preston's all right. We got some people on. Awesome. So just click the sticky note and add your thoughts. I will go over so that you can see it again. Let's take about 60 seconds to get your thoughts. Feel free to add more than one. Okay, again, you do not just have to stop at one. If you know multiple rules, if you want to add on to someone else's, please go right ahead. Really want to focus on two. If you haven't commented on any of these ones on the bottom right, let's look at some of these. What happens when we do these things? Let's see what we've got. One over everything. Exponent rules for add them together. All right. I like it. Let's keep going. What other ideas can we come up with? Multiplying two expressions, same base. That's going to be really important. I like that. If we go back to our examples, in order for us to multiply or to add or subtract these, like what I'm seeing, we have to have the same base. So this example is x squared times x to the third. X is the same base, so we can go ahead and add them. If you do not have the same base, you cannot necessarily add your exponents. Whereas if I look at this example, okay, 8p times 2p squared. 8 times 2 gives me 16. And because p is the base in both of these, I can do p to the first times p to the second. 1 plus 2 gives me 3. So I have to do that for each term, but I'm able to get 16p to the third by saying, okay, 8 times 2 is 16. This is p to the first. P to the first times p squared. 1 plus 2 gives me 3. Okay, let's jump back there. Awesome. Exponent rules for division, 1 over everything. Just be careful. I think I know what you're talking about right here. If we put 1 over everything, that happens to do, and you can see it here. Oops. You can see it here and you can see it here. Negative exponents. So when we have a negative exponent, we move it into the denominator. So just be careful. I think that's what you meant to say. I just want to clarify. Negative exponents make our number smaller. That's why we put it in the denominator, because as my denominator gets bigger, I'm breaking it into smaller pieces. I have 1/2 the pie, 1/4 of the pie, 1/10 of the pie, 1/100th of the pie. As your denominator gets bigger, your number gets smaller. Okay, so again, continuing on with polynomials. Okay, so whatever the highest degree. So we're going to talk about, maybe I'll share my iPad, and again, make sure you remember this stuff, write this down if you don't think you've got it memorized yet. But when we classify polynomials, there's two things that we really like to look at, okay? The first thing is that we like to look at the leading coefficient and the highest degree. So normally we put the highest degree first, but not always. And that's what that slide was showing us. It was showing us what happens when I have the highest degree. So if your highest degree is 0, that's like saying x to the 0 power, that's just 1. So it's going to be a straight line. We're used to saying, hey, 1/2 x, rise 1, run 2, or 3x, rise up 3 over 1. That's linear. That's going to be a straight line. Quadratic, we've spent time with, and that's going to be when you have an x squared. And then there's a few other ones. Cubic's really common. Quartic is 4. Quintic is 5. And then really after that, we just call it the nth degree. Now, what we are trying to get at, and I want you guys to kind of help me out with this, is there something that we can say that's true about when our highest degree is odd? What happens when our highest degree is even? So these are some examples, okay? And we'll talk about the leading degrees or the coefficients, the leading degrees in even or odd. So in this first example, my number or my left endpoint is going down, my right on the right side is going up. They're going opposite directions, so we would say that this is an odd function. In number 2, okay, I have a left endpoint going up and a right endpoint going up. These are going in the same direction, so we would say that this is an even function, which means my highest degree is 2, my highest degree is 4, my highest degree is 10, something like that. And because it's opening up, if you think about it, can it catch water? Could this catch water, or would the water just run off? If it can catch water, we say it's concave up, it's opening up, and that means you have a positive leading degree. So a positive leading coefficient means your answer is your parabola, whatever your graph is going to open up. Whereas when I look at 3, this is an even function because both my ends are going down. This would not hold water. If it was raining, the water would slide off. This is concave down, which means my leading coefficient is negative. Okay? My leading coefficient is negative. So I'm going to put the link for the Jambox in the chat again. Go to the second page and just summarize what we just talked about with our with even functions and odd functions. So scroll over to the second. I see Cardon's back on. Awesome, Preston. Create a new sticky note and describe some of the characteristics of even functions, some of the characteristics of odd functions. And if you wanted to talk about a leading coefficient, you could do that as well. So click on that chat and let's add some thoughts. Oh, I see. So again, this is if you even functions, this goes on page 2. So hit the arrow at the top and then go to the second page to add your even and odd ideas. Come on. There we go. Okay, even functions will point in the same direction. Yep, they'll either both be going up or they'll both be going down. And kind of similar to that, odd functions will not. Okay. Yes, so that's another way. I thank you, Holly. We can do this algebraically as well. And so if we plug in a negative for our x value, our y value should be the exact same thing. I love that. Thank you for reminding me. So that's a way to prove even functions algebraically. And then similarly, odd functions, one side goes up, one side goes down, it's not going to equal. So f of net parentheses negative x would equal negative f parentheses x. And I can put that up here. Let's add that. So odd would be all right. So check that out. So that's another way to prove algebraically. Awesome job. Thank you for that. All right. Last part is we talked about adding, subtracting, multiplying polynomials. Gonna get to this. Gonna try to kind of go quick so that you get practice time. So gonna talk about these. I don't know what that was. Okay. So looking at this, I can only combine like terms, which means, hey, if this has an r to the third and this has an r to the third, I can add them. If they don't have the same base, the same exponents, I can't add them. So I would add these two up and say 7 plus 4, 11 r to the third, 5r squared. There's no other 5r squareds, so I'd leave it alone. There's 5r and 8r, so that would add to 13r. And then there's no other 7 to the r to the fourths, so this would stay a negative 7r to the fourth. So the leading coefficient is negative. The highest degree is 4, so this would open down and be an even function. It would open down and have an even function. The important thing to remember about subtraction is this negative sign goes to every single term. Oops. So negative 3 is really positive 3. So I would add 3n to the fourth. So negative 2n fourth plus 3n fourth is 1n to the fourth. Negative 7 is positive 7. So 7n to the third minus 5n to the third is 2n to the third. And then this negative turns this one negative. So negative 7 minus 1 is negative 8. So I got to keep my like terms together, and I got to make sure to distribute that negative. Multiplication can take a little bit longer. You just have to take this first term and multiply it every single time. So remember, negative 5n times positive 6. Negative times positive is negative. This is like saying n to the first. So n times n squared is n to the third. So negative 30 n to the third. Multiply here, and then you have to do everything again with this negative 7. Negative 7 times 6n squared. Negative 7 times this. Negative 7 times this. So you got to write all that out, and then you have to combine it and cancel out things. So let's get some examples. And again, I know I went through that fast. I want you to get some practice time. If you want to see it more in depth, watch the Unit 5 Lesson 3 video, okay? That video will be your best friend. All right, posting the link in the chat. I want everyone to participate, okay? It's not optional. I want you to do this and practice as much as you can. We'll go about 4 minutes. All right, let's start. All right. Preston, Holly, Georgia, awesome. Let's get everybody in. Let me see, how many people do we have today? We've got 5. Again, really light today. We've got 4 of you in. Let's get one more. Who we missing? The Ali brothers. Just the one today. That was geometry. All right, let's see here. Abdisanir, can you please click the link and join? I'm going to scroll through, share my screen. So those of you that are watching the recording, please pause, try the problem, click play, go ahead, try again. So pause it, try it on your own, continue on. Oops. Awesome. Keep working hard. Let's go about 60 more seconds. I know you're not going to finish, but try to get a few more problems in, and then we'll wrap up. All right. Good work with that. Again, just wanted us to get some real quick practice in adding, subtracting, and multiplying. Let's look at our Class Connect assignment since we're already at 10:26. All right. So again, you can always find this right here. It's one of the first folders. Publish this. Go ahead, simplify this problem. Again, remember an exponent to an exponent is multiplication. When you multiply same base, you add. So you got to use 3 times 2 here. You got to add 4 plus 3, and then you got to simplify that. This is an even function, true or false. Again, look at the end behavior. Where is the left side going? Where is the right side going? Is that a characteristic of an even function? And then go ahead and simplify these 3 problems. Remember to distribute this negative, straight up addition, combine like terms, and then multiply this out. Remember, this negative 8x goes into each term. This negative 1 goes into each term. Add them up, combine like terms, and there you go. Looking ahead, again, if we just look ahead, we've got a Class Connect next week, and then we've got almost a full week, but we're not going to meet that last week before winter break because it is a short week. There's no school on Friday. So I'll see you next week, same time, same place. And then after that, we won't meet again till the following year. Let me know if you have any questions, concerns, comments, and I would be happy to meet or help in any way that I can. All right. Have a good one.